sincere? Come on, let us know. So we are having 100% live interactive classes over here so that we can face to face listen to your doubts and clear them. Next, we have personalized attention. How personalized? Because in every batch we are having maximum to maximum 6 students so that we can focus on to every student. And you will also have a dedicated team which will always look after you so that we can clear your doubts and we can understand your problems better. And we will be covering your school's our syllabus as per your school syllabus so that you don't find any difficulty in your exams. Okay, now let us see what are the key features of Swiflearn. So key features are, first of all, Swiflearn academic test series. Okay, why is it special? Because here you can compete with thousands of your peers and see your position and you can improve accordingly. You can also take unlimited practice tests. You will have detailed progress report which will tell you everything. Where are you perfect, where are you lagging, and what are the things that you need to work upon. And you have subjective test. So what is the importance of subjective test? To practice answer writing. Having said that, let us begin with our chapter, and before beginning I would like to tell every one of you to please like and subscribe this video and press the bell icon so that you don't miss out on any update from Swiflearn. Okay, so we were studying about matter and its composition, and we have completed 2 of the sessions of matter and composition, right? And if you have missed any of the video, you can just go to the Swiflearn channel, you can search in the playlist and you will get all your lessons there, right? So let us begin with our 3rd session of matter and its composition. So see, what are we going to cover today? States of matter and how does this interconversion happens between states of matter. ओके, दैट इज एक पर्टिकुलर स्टेट ऑफ मैटर किस तरह से खुद को दूसरे में चेंज करता है. नेक्स्ट वी आर गोइंग टू लर्न अबाउट temperature. What is the role of temperature in changing the state of matter? Okay, and next we are going to learn about the role of pressure. Like pressure apply करने पर किस तरह से एक state of matter दूसरे में खुद को change करता है. Let us quickly begin. Okay, so I hope every one of you are ready. Let's start. You have observed ice, water and vapor many times, right? Obviously we have observed ice, water and vapors. And in what forms do they exist? Okay, so the matter exists in 3 different states. Yeah, we were learning about this since 2 sessions. So matter exists in 3 states: solid, liquid and gas. Okay, so the 3 states of matter, they are solid, liquid and gas. All right. Okay, the state of matter, like why is this difference arising? Why there is a difference between different states of matter? Can anybody tell me? It is due to variation in the characteristics of particles of matter. Okay, and how is it different? Let us see. Okay, now let's see about some particles. A pencil, a needle and a wooden stick. We are taking 3 materials: pencil, needle and a wooden stick. Okay, so tell me, do these particles have a definite shape or a distinct boundaries and fixed volume? Let's say if I take this pen in my hand, okay, I can see it is having a definite shape. The shape is not changing. It is having distinct boundaries and a fixed volume, right? So can you conclude what is it? Let's see. Okay, so let's see the shape of the given articles, right? Pencil, needle and a stick, normally they are of these shapes. Okay, and what we can conclude? We can conclude that these are having distinct boundaries, a definite shape and definite volume. Can you tell me these are the characteristics of which state of matter? These are the characteristics of solid. So solid, they have distinct boundaries, they have definite shape and a fixed volume. Also, they have negligible compression. Compression as in we cannot apply pressure to change the shape of solid. Okay. Now, what will happen if we hit pencil, needle or a wooden stick with hammer? अगर हम उसे हैमर से बीट करते हैं तो उस पर क्या रिएक्शन होता है? Are we be able to change the shape of pencil, needle or anything? No. We cannot change the shape. Okay, that is, the articles do not diffuse into each other, they do not mix into each other when we hit them by hammer. Yes, so what does this conclude? This concludes that solids, they have this tendency to maintain their shape when subjected to outside force. अगर हम outside force apply करते हैं solid पर तो भी उनका जो shape है वो rigid रहता है. It doesn't change easily. Yes? Okay. So these examples were of solid, and we have concluded that solids, they have a definite shape, distinct boundaries and fixed volume. So these are three most of the important characteristics of solid. Okay, definite shape, distinct boundaries and fixed volume. Okay, they also have this tendency to maintain their shape when subjected to outside force. They may break under the force, but it is difficult to change their shape. Okay, so if I take a simple example of this pen, okay, if I hit it with hammer, it won't change the shape. ये अपनी शेप चेंज नहीं करेगा, बट अगर मैं बहुत ज़ोर से हैमर से हिट करती हूँ तो एक पॉइंट के बाद ये पेन ब्रेक हो जाएगा. इट विल जस्ट ब्रेक. ओके, सो इट इज़ नॉट पॉसिबल टू चेंज द शेप, okay, by applying outside force to solid. Okay, but if we apply excessive force, जितना ये ले सकता है उससे ज़्यादा अगर हम force apply करते हैं, then it will just break. So this proves that solids are rigid. Okay, let's move forward. Solids have definite shape, distinct boundaries, fixed volumes and are rigid. Next is intermolecular forces of attraction are strongest and intermolecular distance between particles is very least. So let me explain you by taking this example. Let us consider this is a block of solid. Okay, and if this is the block of solid, the particles in the solid, they are tightly packed. Okay, तो ये जो particles है, let us consider these are the particles. So these will be very tightly packed. Okay, there will be this minimum space between them. Okay, so this proves the intermolecular space is very less. Okay, so let us can you see these spaces between the particles? So these spaces, they are very less space. Yes, which proves intermolecular distance between the particles is very least. जो मॉलिक्यूल के बीच का डिस्टेंस होता है सॉलिड पार्टिकल्स में, सॉलिड मटेरियल्स में, वो बहुत ही कम होता है, जिसकी वजह से द इंटरमॉलिक्यूलर फोर्सेस ऑफ अट्रैक्शन दे आर द स्ट्रॉन्गेस्ट. ओके, हाउ द फोर्सेस ऑफ अट्रैक्शन आर स्ट्रॉन्गेस्ट? सी द पार्टिकल्स आर टाइटली पैक्ड. ओके, so this particular molecule, it will exert force on this one, this one, this one, this one. Okay, so it will hold itself together. Okay, so that is why the intermolecular force is greatest. Okay, now the rate of diffusion is very less. So if the particles, they are holding each other very tightly, they cannot be flowing here and there, right? अगर particles एक दूसरे को जकड़े हुए हैं, पकड़े हुए हैं tightly, तो जो particles है, जो molecules है, they cannot be running away, they cannot be flowing away, and hence solids have got a definite shape, distinct boundaries and fixed volumes. Okay, now let's consider an example of a rubber band. Okay, if I take any example of rubber band, what happens if I stretch it? Okay, if I apply force and if I stretch the rubber band, what will happen? It will change its shape. Okay, it will be extended like this. Okay, but what if I remove my hand? it will again come to its original shape. वो वापस से उसी shape पर आ जाएगा, है ना? But when I apply excessive force, okay, if I apply excessive force and I keep pulling it, what will happen? At one point, after one point of time, it will break. Okay, तो एक particular point of time के बाद जब force बहुत ज़्यादा हो जाता है, जो है solids, they break. Okay, now you might be thinking we have sponges. Okay, that is also a solid that is having a distinct shape, boundaries, but we are able to change its shape. How? Let us see how. So the sponge, it has very small holes in it, right? So whenever we compress it, what happens? The air comes out. Okay, the sponge, the air is trapped inside the holes. Okay, and when we compress the sponge, the air comes out and we are able to change the shape of the sponge, and that is why it is able to change the shape. But when we remove it, when we remove our hand, the sponge comes back to its original shape. वो वापस से उसी shape पर आ जाता है. अच्छा, now let us take example of liquid. Okay, let's consider water and milk. Okay, if we open the bottle of milk and if we spill it on the floor, what will happen? Yes, obviously your mama will scold you, but the milk will change its shape, right? Well, what does it prove? It proves that if liquid is passed on from one container to another, it changes its shape. Okay, if we transfer water or any other liquid from one container to another, let us consider I am transferring water from jug to a glass. What will happen? The water which took the shape of jug in the first condition, now it will be taking the shape of the glass. तो जो water ने जग का shape ले रखा था, वो pour करने के बाद glass का shape लेगा, right? You can see it here. Here also we have water, and here also we do have water. Okay, but in the first condition, the water, it has taken the shape of glass, and in the second condition, the water, it has taken the shape of a laboratory beaker. What does it prove? It proves that if we transfer liquid into different containers, it takes the shape of the container. Okay, which means milk, water, liquids, they are not rigid. They flow and they can change their shape. And how does they change their shape? They take the shape of the container. वो जिस भी कंटेनर में पोर किए जाते हैं, उस कंटेनर का शेप ऑक्यूपाई कर लेते हैं. I think this is very clear to all of you. Okay, so as milk is liquid, so the properties of liquid we can give as liquids, they have no fixed shape and they are not rigid. Means solids take the shape of the container they are poured in, and they have fixed volume. Like if I transfer 1 liter of water from a jug to a glass, that will remain 1 liter only, but the shape will be changing. Okay, तो volume हमेशा liquid का fix रहता है, but no shape, and they are not rigid. Now let's see about properties of liquid. Liquid की properties क्या होती है? Okay, so first of all, before going on to properties, let's see a diagram. Okay, let us consider this is depicting liquid particles. Okay, the liquid particles, they are arranged in this manner. Okay, so what you can conclude from this diagram, जो interparticle space है, it is a bit high than solids. Okay, in solids there was absolutely no interparticle space. Okay, so therefore in liquids we have a bit more of interparticle space or intermolecular distance, and therefore the force of attraction, it is bit less. Okay, because space is little more, therefore attraction will be little less. Okay, So it will be bit less than the solids. Okay. Next, it's note that solid, liquid and gases can diffuse into liquids, which means solid, liquid and gas, they can diffuse, they can be mixed into the liquids. How? Let us see. So let us consider, if I take a spoonful of sugar and if I dissolve it in water, what will happen? After some time, this sugar will be dissolved in water, which proves sugar is a solid and water is liquid. So solid and liquid, we can dissolve solid in liquid. Next, if I talk about liquid and liquid, so if I take a spoon of ink, okay, and if I dissolve in water, what will happen? After some time, the water in the container, it will change its shape. Okay, so that proves liquid can also be diffused in liquids. And thirdly, talking about gas, we can dissolve oxygen into water, right? And that is why gases can also be diffused into liquids. Okay, so how to prove the gases can be dissolved or diffused into liquids? The fishes, okay, they take in air, they don't come up again and again, they take in the oxygen which is dissolved into water, which is liquid. Okay, now see, what is the state of mixture when a teaspoon of solid salt, if we take a spoon of solid salt and we dissolve it into glass of liquid water, what will happen? The salt, it will get mixed. And how? Because I told you that liquid, it is having some interparticle spaces between them. So the salt take up those spaces and it gets dissolved into the water. Okay, and what will be the final phase? It will remain liquid only. Okay, so what are the characteristics of liquid we saw? First one, they do not have definite shape, but they do have a definite volume. They are not rigid like solids, and they can take the shape of any container they are poured in. Like if I pour water from a glass to jug, it will change the shape from glass to jug. If I spill the water on the floor, it will spread. So they do not have definite shape, but that volume will remain the same. It won't happen that if I am transferring the water from jug to glass, it will change from 1 liter to 2 liter. Okay, it will remain the same. Now let us talk about balloon. Okay, if you observe a balloon, what is it filled with? Obviously air. Okay, but have you ever wondered, like, how does a balloon seller fills a large number of balloons from a single cylinder of gases? You must have observed that a balloon seller, he is having the cylinder of gas with him. Okay, and that is not very big, that is small. So how is it possible? Let's see. So gas in the cylinder, I told you the gases are highly compressible. We can apply pressure to them. Yes, so the gas in the cylinder, they are highly compressible and it can store large volume of air in one single cylinder. Okay, so therefore, because the large amount of or large volume of air is filled in the cylinder, we can fill in air in large number of balloons. Okay, all right, so let's do an activity. Okay, if okay, I'll request, if you're doing this activity, you might need a little bit big bottle, okay, so that you can see the results. So what we have to do is, we have to take a plastic bottle which is shown over here, and we have to tie a balloon at the mouth of the bottle. Okay, and now we are going to place it in a container, tray like container, and then we are pouring the water. We are going to pour the hot water, okay, or we can also pour water and heat it from bottom. Okay, what change will you observe? What will happen? The air which is present in this bottle, it will rise up and it will inflate the balloon. Okay, so what do we conclude by this activity? When hot water is added, the air in this bottle, it gets expanded, and air from this bottle, it gets transferred into balloon, and balloon gets filled with the air. Okay, So there is one principle also of this. We have hot air balloons, right? So hot air balloons, they work on the same principle. Okay, when heat is applied from the bottom, the air rises up and hence it makes the balloon to rise up. Now let's talk about gas. So we just saw that gases are highly compressible, and that is why the balloon man, he can store a large amount of gas in the cylinder. Next, they expand to fill the container and take up the shape of container. So the gases, the particles of gases, they flow endlessly and they expand to fill the container fully. Okay, and they take shape of the container. And they, because they expand highly, so therefore they need very much, or I can say they need more space than in liquids or solids from which they are formed. Okay, so what are the properties of gases? First of all, intermolecular force of attraction are very least. Okay, so let's go back there. Let's see how are gases formed. So if this is I can say a particle, so the molecules of gases are spread in such a way that these are having very high, very large spaces between them. Okay, and if the space is very large between the particles of gas, what will happen? This particular particle, it cannot exert very much force on this particle. Okay, so therefore if the space is very high, the force will be very low. Okay, so intermolecular force of attraction will be very least, and therefore the particle of gases, they keep on flowing here and there. I hope you are very clear with that. Okay, and the rate of diffusion is fastest in the gases than in solids or liquids. Okay, how does it happen? Now see, how is rate of diffusion fastest? The particles, they keep on moving here and there, right? And that is why they can diffuse very easily. Okay, so when we saw about rate of diffusion, it was least in the solids. Why? Because the particles are very, very closely packed. Okay, then if I talk about liquids, the rate of diffusion was a little bit more than solid, and gases, they have highest rate of diffusion. Okay, all right. Having said that, among the three states of matter, the greatest intermolecular distance between its particles, so which particle of matter they are having greatest space? It is the gases. Okay, the gases, they have very much space, and therefore the force of attraction is very, very less. Okay, and intermolecular distance between the particles, it is highest in the gases because they are having this large intermolecular distance. Okay, then the liquids, and then the solids. Why solids? Because solids are very tightly, very rigidly packed, and they cannot change their shape, they cannot move here and there. Okay, so the gases, they have greatest intermolecular distance. Okay, and therefore force is very less. The liquids, they have intermolecular distance a bit less than gases but more than solids, and solids have least intermolecular distance. Okay, now let's see how the states of matter change from one state to another. Okay, so they are converting their form from one state to another. Okay, and there is no change in their chemical property. And how does this change happen? This change happen by bringing up a change in temperature and the pressure. So what will happen? Let's take a case of solid. Okay, if we are taking case of solid, let's take ice, and what will happen if we apply heat to the ice? It will change to liquid form. So it will change its state from solid to liquid, and if we continue apply heat to it, it will soon turn into the vapors, which will be taking the form of gaseous state of matter. Okay, but during this change there is no chemical change happen, it is just a physical change. And what will happen if we cool the vapors? It will slowly turn to liquid, and from liquid it will turn to solid if we refrigerate it. So how does this change of matter happen? What did we do in the previous activity? We changed the temperature. Okay, so when we are increasing the temperature, the solid, it changes to liquid, and on further heating it will be changing its state to vapors, which is gaseous state. But when we are decreasing the temperature, the water vapor, they will convert themselves to liquid, and from liquid, on further cooling, it will change to solid forms. Okay, so let's see over here. When solid, okay, we are increasing the temperature, it will melt. So solid to liquid, it is known as melting, and from liquid to vapor, it is known as vaporization, because it is forming the vapor. Okay, then if I take the vapor, okay, and if I condense it, okay, it is also known as liquefaction. It will change its state to liquid, and from liquid on freezing, okay, or it is known, the process is known as solidification. It will change its state from liquid to solid. Okay, now let's talk about change in states of matter by changing in pressure. Right now we saw how does the change happen in states of matter by changing the temperature. When pressure is applied onto some gases, they change into liquid. Okay, for example, liquefied petroleum gas. So when we apply pressure onto some gases, they change their form from the gas to the liquid form. And when pressure is removed or pressure is reduced, they come back to their original gaseous state. So how we can see, like if there is some gas, okay, if we are applying pressure, it will change its form to liquid. Okay, then what are we doing? If we are removing the pressure, okay, if we are reducing the pressure, then it will again change from liquid to the gaseous state. Let us see what is the use of it in our daily life. So we all are having this LPG or cooking cylinders at our house, right? So what happens in those cylinders, the gas is stored at a very high pressure, okay, and the gas which is present in the cylinder, it is of liquid form, it is in the liquid form, okay, and whenever we open the walls of regulator, okay, what happens, the pressure, it gets reduced, and now it again comes out in the gaseous form. So when we are putting in under high pressure, it changes its form to liquid, and when we are reducing the pressure by opening the valve of regulator, it comes out again in the form of gaseous form. Okay, let's take one more similar example. When liquid gasoline is burnt in a car, okay, so when we put a fuel in the car and when we burn it, it turns into gases. Okay, so when we are heating, it turns into various gases which go in the air, okay, from the exhaust pipe. And if I talk about liquid oxygen, so if we liquefy the oxygen gas, it has magnetic properties, okay, and it can be moved around and even picked up with a powerful magnet. So liquid oxygen, it has magnetic properties in it. And the last one, the air we breathe, it's made up of different gases, but it is mostly nitrogen and oxygen. Why is it nitrogen and oxygen? Because nitrogen and oxygen, they make up about the most of gases present in the atmosphere. Nitrogen is approximately 78% of the total air present in the atmosphere, and oxygen accounts up to 21%. And all the other gases like carbon dioxide, argon, etc., etc., they constitute of 1% only. So nitrogen is the most abundant gas which is present in our atmosphere. Talking about the challenge of the day, it's said, why do solids have definite shape? Okay, so what we can say, the solids having definite shape, first of all, the particles of solid, they are closely packed. Then solid have rigid shape, okay, they cannot change their shape. And next one is intermolecular space is very less. Okay, so this accounts for the same point. And at the last, what we can say, intermolecular force of attraction is highest. Okay, so because of these all reasons, the solids, they account for a definite shape and they are very very rigid. I hope you might have got the answer of why are solids having a definite shape. Now let's do an activity based upon what we have learned in today's class. So boiling point of water, it is 100 degrees Celsius, and freezing it at 0 degrees Celsius. At 0 degree it turns into ice, and at 100 degree water turns into vapors. Dash have definite shape, distinct boundaries and fixed volumes. So obviously we just now saw solid have definite shape, distinct boundaries and fixed volumes. When temperature is decreased, solid changes into liquid. So when we are decreasing temperature, solid doesn't change into liquid. Okay, and the movement of particles in a liquid is, it is in random motion. So yesterday we saw that the particles are moving in a random motion, and we also saw that the zigzag movement of the particles, it is known as Brownian movement, or we can also say Brownian motion, which is also known as pedicis. Okay, having said that, let's go back to our chapter. Let's see what we have learned today. So name all the three states of matter: solid, liquid and gas. Okay, next list any two characteristics of solids. So the two characteristics of solids, they are having definite shape and they are having definite volume. They are very rigid. The interparticle space between particles of solid, it is very less, and therefore attraction is very very high. Liquids, they do not have a definite shape. Can you tell me why? They just take the shape of whatever container they are poured in, because they are not rigid. Okay, and they can mix up. What do you mean by interconversion of states of matter? So let us see this question. When I talk about interconversion of states of matter, it means conversion of solid to liquid to gas, and again conversion of gas to liquid to solid, which means changing of one state of matter to another. It is known as interconversion. And today we saw how is it possible, by changing the temperature and by changing the, or by applying the pressure. Okay, this is how we can change one state of matter to another. LPG is stored in the cylinders at very high pressure. Okay, so that it turns to liquid, and then whenever we are opening walls of the cylinder, it turns into gas. Alright, so I hope you all must have understood the chapter very well. Let us meet tomorrow with something new to learn. Till then, keep revising, keep learning and